Hi, this is Kevin. Welcome to my Beyond the Textbook lecture for uh, chapter 14 of the Severance textbook. Chapter 14 was about creating custom Python classes. And we're going to go through some features and tools and techniques that were not included in the chapter. Uh, I really like the chapter. I just want to add to it. So, one thing that I want to add about classes uh, is it's really helpful. It's really helpful to think about classes having responsibilities. Okay. And I'll try to emphasize that as we go through the material here. So, as we know from the textbook, classes are blueprints for creating programming objects. Okay. And programming objects, or objects as we call them, are just instances of classes. Programming objects have both data and behavior. The data is carried in the instance variables, often called the fields, and the behavior is implemented in the methods. So the responsibilities of classes are really divided between the responsibilities to know data and the responsibilities to do behavior. So the data responsibilities are implemented with instance variables, and the behavior responsibilities are implemented with methods. There are all kinds of classes that one could design and implement. And in fact, when you consider that most of the parts of Python that we've been using for the course are implemented with Python classes, you can really see that there is a wide range of responsibilities that those kind of classes can have. So when we start to learn about designing and implementing our own custom classes, one kind of class that's kind of easy to understand and practice on are these things that are commonly called data classes. Okay? And they have high data responsibilities and lower behavior responsibilities. Okay? And we call them data classes. So what's the purpose of this kind of class and the objects that we can create from this kind of class? Well, their purpose is to hold a related set of data facts. It could be a record from a data file. It could be a row from a relational database table. Or it could be a row from a spreadsheet. And having these kinds of classes to create these kinds of programming objects make the processing of data records or rows easier, particularly when we want to sort them. Okay? So we have this great feature that came into Python fairly recently in Python 3.7 called data classes, all one word, and it's implemented with a package that's part of um, the Python standard library called data classes. Okay. And where could you find some information on that? Because it's not in our textbook. Well, there are two places that I point you to from the weekly schedule in our class. One is in the Python documentation, which in the current semester is for Python 3.10. There is a section on data classes. Okay, and this is the documentation on data classes, and it's pretty good. It's a good introduction. Okay, uh, the other resource that I point you to from the weekly schedule is an article in the real Python site called Data Classes in Python 3.7 Plus, and it's a guide. And I think this is a great introduction. It's pretty comprehensive, and although they do some kind of interesting things with playing cards here that are maybe sort of above our pay grade, there's a lot of good stuff here that I think it's a good article to read. Okay, so that's where to find your reading. So the way we turn a class into a data class is just in the line before we declare the class, we just include this decorator, and decorators in Python always begin with an @, and it just says @ data class, and of course you have to do the corresponding import for that from the data classes package. And so what is interesting is when we use the data classes feature, three of the methods that are really key to building a useful class are built for us automatically. And those are dunder init, dunder repr, and dunder eq. And the init is the constructor, so that it constructs new instances, and implicit in that is it defines all the instance variables. Okay, the repr is a method that we use to get a string representation of our programming object. And that, so if we print an instance of an object, it will cause a call to repr, and we'll see an automatically generated version of the data that's in that instance. And this EQ, or equal, this allows us to compare one instance of a programming object with another instance with the equal operator. Okay, it won't allow us to compare greater than or less than. We'd have to implement further methods in our class, for instance, to support sorting, right? But we can compare and look for equal instances of the class. Okay, so I'm going to go through two programs. One is a class called state, and it's in a library module called myState. And the other is some client code that uses it called create state area reports. And those two can be found in the supplementary project for this chapter, which is called Demonstrations to Supplement Severance Chapter 14, and that's available in the weekly schedule for this course. One thing that we're going to explore in a bit, and I just want to mention while I'm here, is that we can even use the data classes feature to create class hierarchies of, superclasses and subclasses. Okay, but let's not get ahead of ourselves. I just wanted to mention that. So let's look at the state class in my states. Okay, so my states is right here. And I'm going to open up the state class. And let's see, I've done two imports here. One is if I want to use the data class feature, I need to import the data classes library package. And the only item that we're using is data class. So I'm going to import it explicitly. And I'm also using these IS430 unit test helpers. And from that, I'm using assert equal and assert equal float, and I'm using that for my unit testing. Okay, and the entire class is right here. Okay, pretty interesting stuff. So we begin with the data class decorator. And of course, if you don't do the import, if we take the import up here and we toggle it into a comment, that's going to break and say that it can't find data class. So if you want to use the data class decorator, you need to import the package. Okay? And the way we start a class is just use the keyword class, and then we have the name of the class. And whereas most names in Python use an approach to capitalization and separating the words called snake case, in which the names are all in lowercase and the words are separated by underscores. Python classes use an approach to capitalization and word separation called camel case. And this is probably more typical in object-oriented languages. It's the one they use in Java, for instance. And each word begins with a capital, so the S in state is capitalized. And subsequent words begin with a capital, and there are no separating underscores. Okay, so just state. And what we do is that we list out the names of the instance variables, followed by a colon, and then the name of the class that indicates the type. So we have a state name, which is a string. We have land area in square miles, which is a float. And then we have water area in square miles, which is a float. Okay? Now, you'll notice that I don't have anything for a constructor. I don't explicitly have an init. I don't have anything to create anything explicit that creates a string representation like an str, a dunder str, or a dunder repr. Okay, and I don't have an EQ, a dunder EQ, but these are created as part of the Python magic by this data class decorator. So they're there, we just don't have to code them explicitly. Okay? So we get 3 methods for free. Okay? And then we need to implement the methods that we want, okay? And in this one, we're going to create a method called calculate total area in square miles, okay? And it's going to return the land area in square miles plus the water area in square miles. And you will recall from the textbook that if you want to refer to an instance variable, you have to prefix them by self dot. And it's particularly important that we kind of understand why we're creating the method here. Generally speaking, it's considered bad practice to store data that can be calculated from the other data that we store. So a total area in square miles is interesting for our application, but it's just the sum of the land area and the water area. So we don't want to store it explicitly. And yet we want to control the way that it's calculated. Now, you might argue it's simple addition. How could anybody get that wrong? In which case, you'd probably think of this as a convenience kind of method that makes it easy for people to use our class. Okay? Note that the name of the method begins with a verb. Okay? We want to differentiate between instance variables that have names that are nouns or noun phrases and methods which have names that are typically verb noun phrases. Calculate total area in square miles. Okay, and this is the whole thing. So what's the rest of the code that we have here? Well, it's our unit testing. And in our class, we're not using one of the formal unit testing frameworks like unit test or PyTest. Maybe we will in a semester or two or a year or two. But we've decided to have a sort of homegrown approach to unit testing that uses the same principles as unit testing frameworks. And so whereas in unit testing framework, for each class of our real code, our production code, we'd have a shadow class that was the test for that class. Here, what we're doing is we're putting the tests right into main. Okay? And we're testing two things. One is we're going to test the constructor. Okay? And so we print unit testing output follows, and then we print the name of the test case. At one time in my course, I was numbering the test cases, and I realized that that probably isn't a good idea because as you refactor a class or as you expand it, you're probably going to want to insert tests in between tests that you already have, test cases that you already have, and you don't want to have to renumber things. So my new version here is I just say test case, and in this case we're going to test the constructor. So we set the expected values, the expected state name is Alaska, expected land area in square miles is a number that I made up, the expected water area in square miles is another amount that I made up, okay? And so I construct a new state. In this case, I've called it S1. It probably would have been better to call it state 1. And I passed in the expected values. Okay. Now, it's interesting to see here. You might wonder, what order are the parameters expected in your constructor? Well, the same order that they showed up in your list of the fields. Okay. The constructor that they generate for you automatically is going to be in the same order. And then I do an assert equal that the expected state name is equal to the actual state name, that the expected land area in square miles is equal to the actual, and the expected water area in square miles is equal to the actual as well. Okay, so let's do a unit test of that. I'm going to toggle the second of the unit test into a comment. Okay, and we're going to give it a run. And we can see that we had 3 tests in the test case and they all passed. Okay, and now the next thing I want to do is I want to test the method. Okay. And so the beginning information is the same. Okay. I predict the expected total area in square miles, and I believe I did this with a calculator. And then I construct the object again, and I do an assert equal float because I'm getting a float value back. Okay. And I see that these are I see that I made a mistake on the prior test, and we'll go back and we'll fix that in a second. Okay, so we do an assert equal float where we have the expected, we have the actual, and then we provide a delta value in case the value is off a little bit by rounding. And I said it's got to be within 1/10,000th. Okay, and let's run this. On my states, and we're going to see that passed. Now, what mistake I make earlier? Well, these 2 values up here that I tested before with an assert equal, they're float values, and I probably should have done an assert equal float. Okay, on each of these. Assert equal float, which means that I ought to do the same thing. Let's put that third value in and say it's got to be within 1/10,000th. So we're going to put that there, and we're going to put that there. And that's a more robust way to compare floats. All right. All right, so let's give that a run. And it's going to turn out that they passed. Okay, so that error's been sitting there for a while. I just found it. Okay, so this is pretty much all you have to do to create an ironclad data class. Do you have to unit test it? Well, I think some more haphazard practitioners might not. But certainly your custom method needs to be unit tested. It wasn't automatically generated by Python. Somebody could argue that The constructor was automatically generated by Python, and maybe you don't have to unit test that. I think that unit testing it is a good practice. Okay? Okay, so that's my states and the state class. So uh, that's the class code. What would be an example of client code? Well, we're going to take a look at create state area reports. And here we've got this. I'm going to close this window down here. And in my class, we've already created this kind of program back when we were working on Zell Chapter 11. We were learning how to use a class like this, a data class, without having to create it ourselves. And I may have given you an early version of this exact class. I forget. This could have been the one that I used in the tutorial. It probably was. So we look at the doc stream. Print state area reports in two different sort orders, by state name, by total area in square miles. Why did we decide to do total area in square miles? Well, because we wanted you to have to call the method, right? So we created a function called get. It states where we read the data from a file and we generate a list of state objects. We sort them by state name, okay? And then we call print report. We pass it this states list of state objects, and we say that the title of the report is by state name. And then we sort it again by total area in square miles, reverse equal true to make it descending. And then we call the same print report again. We pass it the same list of states, and the title is by descending population density per square mile. In get states, we're prompting for the file name and we're opening the file. We're creating an empty list to hold the list of my states. We're using a for-in to read the file. These data happen to be split by a semicolon, which is unusual, but that's how I did it. And then for each of these, I split and unpack them into state name, land area as string, water area as string, and then I construct a new state instance and I pass in the values, converting water area as string to a float. And this is interesting. This is the mistake. How about this? I found two mistakes in this. So this should be land area as string. I had to recreate this from something else, and I made some mistakes. How about that? See? Walking through your code can be pretty useful stuff. All right. And then we return the list. Okay. And then when we print the report, we're going to get the list of state objects and the report title. We're going to center the title in 60 spaces. Okay. We're going to print out the 2 lines of column headings, and then we're going to print out the detail from each of the state objects. And here are the two functions that we use to get our sort keys. By state name, we're just returning state name, and by total area in square miles, we're calling the method calculate total area in square miles. So let's give this a test. I'm glad that I've been able to repair the two errors that I had in here. State area data dot text, and here are the data. You can see that they're not the same. I had them the same there for a while. I didn't catch that the last time I tested it. So the first version is in state name order, and the second version is in it's got the name around. I copied this from another thing. So this should be by descending a total area in square miles. My. Sloppy. So this should say by descending total area in square miles. Wow, this is humbling. You can see how testing's pretty important stuff. So I'm going to copy this. This is what my students do to keep having to type that in again. Another important skill learned from students. And so let's see what we have. We have by state name, by descending total area in square miles. Very nice. Okay, so that's that. Okay, so that's how we create a data class ourselves. That's how we design it. That's how we implement it. That's how we test it. That's how we use it with client code. Okay. Let's move on. Okay. You can actually use this Python data classes feature to create hierarchies of superclasses and subclasses. Okay. And this is helpful for all kinds of applications that have data that they have to keep. Okay. Except there are data subtypes. Okay. If this were banking, right? Everything, every record that we have would be for a bank account, but some of them would be savings accounts. Others would be checking accounts, and others would be time deposit accounts, like a certificate of deposit, right? And you could implement those with a superclass bank account and subclasses, savings account, checking account, time deposit account. Okay. And, we talked about superclasses and subclasses when we talked about the chapter. But one of the things that we're going to be taking advantage of is that subclasses have a relationship to their superclass, where you can say the subclass is a superclass. So a savings account is a bank account. A checking account is a bank account. A time deposit account is a bank account. And when you're creating the client code, this turns out to be something that we rely upon pretty heavily. So the way that we allocate responsibilities within a class hierarchy is a superclass implements common instance variables and methods. So everything that would be common to savings account, checking accounts, and time deposit accounts would be implemented in bank account. Okay, the subclasses implement additional instance variables and or methods. So if a savings account has extra data responsibilities, it's going to have extra instance variables. If it has extra behavior responsibilities, it's going to have extra methods. Okay? The same for the others. Subclass methods can override superclass methods. So we can have a default behavior in the superclass, and we can override it with more specific behavior in the subclass. Okay. In addition, subclass methods can add further functionality to superclass methods. So maybe they're not going to fully override them in that sense. They're not going to replace them. They're going to call on the method in the superclass and have that work done, that common work, and then they're going to add to it in the subclass. In our example, we have a pretty good example of how to do that and why. So this differing behavior by methods of the same name in a different class within the hierarchy is known as polymorphism. So polymorphism is a computer science term for the same method having different implementations depending upon the class within the hierarchy that you're in. And one interesting thing that we take advantage of that has to do with polymorphism when we're writing client code is that instances of subclasses know their proper behavior. They know what method they have. And so, for instance, if checking accounts have a special way that they calculate monthly fees, and savings accounts have a special way that they calculate monthly fees, and time deposit accounts have a special way that they calculate monthly fees. When we're in the client code and we call the method calculate monthly fee, okay, depending upon whether we have an instance of a savings account, a checking account, or a time deposit account, the kind of calculation that we're going to get is going to be different, okay? And that's because each instance knows what it's a subclass of, and it has access to just the methods that are appropriate for its subtype. It's really powerful. Okay, so we're going to do an example here in the Beyond the Textbook lecture that's going to carry on to the coding assignment. Okay, so we're going to create a vehicle class hierarchy, and this is going to be for a fictitious Department of Motor Vehicles. When you see the test data, it claims to be in Illinois, but the rules that we have implemented are certainly not the real rules in the state of Illinois, okay? And we're going to begin with a hierarchy that has a superclass named vehicle and two subs, one called car and one called truck. So a car is a vehicle, a truck is a vehicle, okay? So this is going to be our first version of the class code and the client code. And I call it the precursor version because, well, I've got three versions. I've got a precursor version that we're going to look at here. Then we're going to refactor it, and we're going to call that the starter version. Well, what's it a starter of? Well, it's the starter code that you get when you do the coding assignment. And then we're going to have the coding assignment version. And then there's actually going to be a challenge version as well. So why is this a precursor version and not the starter version? Well, it turns out that if you just go ahead and design the class code and the client code the way, kind of naively, the way you would do it after just reading a book on implementing class hierarchies, we have too much of a coupling between the class code and the client code. And how do we know that? Well, because each time we introduce a new subtype, we break the client code. And that turns out to be a bad thing. So we have a car, we have a truck, then we have a motorcycle. Not only do we have to go change the class code, but we have to go change all the client code that uses it, because the client code knows about all the parts of the hierarchy. And we're going to find out this is an opportunity for refactoring, which is going to get us to the next version. Okay, so this is the precursor version. We're going to take a look at my vehicle's precursor, and then that's the class code. And then we're going to take a look at create vehicle registration invoices precursor. Okay, so let's take a look at those. Okay, so let's look at my vehicle's precursor. All right. And so it says here, module contains the vehicle hierarchy of classes and related code, includes sub classes car and truck. Okay. And there we go. And what are we going to import? Well, just the data class within the data classes and the IS430 unit test helpers. And here's a superclass vehicle. Okay, so we just say a class vehicle. That's it. Okay, it has a docstring, a superclass to represent a vehicle. And here are all the fields. So this is a more typical data class, right? We have owner information, their first name, their last name, their street address 1, their street address 2, their city, their state, their zip code, the make, the model, the year, the color, the vehicle ID. And everything is a string except for the year. Okay? So on the basis of this, we would expect, let's go back to one of our slides, we would expect the dunder init, the constructor, the repr, and the EQ to all be generated for us automatically, just because we use the data class decorator. So it's all part of the Python magic of the data class's capability, right? Okay, so right now, uh, the vehicle doesn't have methods, okay, other than the ones that were automatically generated. Okay, so let's look at car. Okay, so car is a subclass of vehicle. We know that because we put the name of the superclass in the parens. And I just want to point out that uh, when you define a superclass, there's nothing that you say that says it's a superclass. It's a superclass because it's used as a superclass by a subclass. Okay? So as soon as we use vehicle as the superclass for car, then uh, we know we have a subclass car and a superclass vehicle, and we give it an appropriate doc string, and we only have one additional field, fuel type, which is a string. Oh, okay. So it turns out that we have a scheme, okay, where fuel type is either electric or hybrid or fossil, okay. Uh, and we do have a method, determine annual registration fee, and that has a doc string and it returns a float, okay. And we have a simple if, elif, else, okay, where we say if it's electric, the annual fee is $100. If it's hybrid, it's $200. If it's fossil, it's $300. And if it's not any of those, then we're going to raise an exception, a value error exception. Okay. Now, I just want to point out that these are not true in Illinois. Okay. In fact, electrics are more expensive than fossils because that's where they pay road tax. So the price of gasoline in Illinois, as well as other states, includes a road use tax. And so because the electric folks are not paying that, they pay more than the fossils for their annual registration fee. But this is from a world in which Kevin is trying to give proper incentive to people to get off of fossil fuels. And so this isn't from the real world. Okay? So that's how that's going to work. So you'll remember that subclasses have superpowers. Okay? Subclasses have more capability than superclasses, and we can see here that in fact a car has one more instance variable and it has a method that the superclass has not got. Okay? Now, what about a truck? Well, a truck is a vehicle. Okay? It has one additional instance variable, gross weight, which is an int. Okay? And it also implements determine annual registration fee. Okay? And in this, we check if the gross weight is left to less than 14,001 pounds. If it is, the annual fee is $400. Else it's $700. And then we return the annual fee. And I just want to point out that these fees are not real. The fees in Illinois are different. Okay, I just made this up. Okay, as I made up the Illinois data. Okay, so this is it. So um, we have a lot of class hierarchy features, right? The two subclasses each implement one more instance variable. Do they have to? No. It's possible to have a subclass that doesn't implement, it doesn't have its own instance variable. Okay. In this case, the car needed to keep track of fuel type because that's how it calculates its annual fee, and the truck implements has to keep track of its gross weight because that's how it calculates its annual fee. Uh, but for instance, if we had a flat annual fee for a particular vehicle type, well, we might not have to keep additional instance variables. Okay? And where does the polymorphism come from? Well, we don't have any implementation of uh, calculate annual fee in the superclass. And in some fancier schemes of how to create class hierarchies, there's a way to say in the superclass, oh, I don't have an implementation of the method, but all the subclasses have to implement something like calculate annual fee. That's not easily done when you're using the data classes features, so we just have no implementation of that here. We're not creating instances of the vehicle. Okay, there's nothing to keep us from doing it mechanically. And again, if we were using more sophisticated approaches to creating a class hierarchy, there are Python features that would help you prevent users of the class in client code from creating an instance of the superclass. But again, when we're using the data classes feature to do this, we don't have that option. But the two things that we are creating instances of, car and vehicle, have different implementations for determine annual registration fee, and that's going to create the polymorphic behavior that we're looking for. Okay? And I'm not going to go into all of my test code here, but I'm just going to talk about what I did test. I set up a bunch of common variables to make it easier to write the test. I tested the constructor for vehicle, even though I don't intend to create instances of vehicle. There is a relationship between the constructors and the subclasses and the constructor and the superclass. So I want to make sure that it works. So I'm going to test it. Then I have some common variables for the subtype car. I test the car constructor. I test the car determine annual registration fee with the fuel type electric, and then I test it with the fuel type hybrid, and then I test it with the fuel type fossil, and then I even test it with the fuel type plutonium, which is going to raise an exception, and I catch that. And then for the truck, I test the constructor, and I test determine annual registration fee with the gross weight of just 14,000 pounds, just under the boundary value okay, and I test it with 14,001 pounds just over the boundary value. And that's it. Okay, and if I were to run this class, it'll run the unit tests, and you can see I'm getting all pass. And you can also see here that I've given up on the idea that I'm going to put a test case number on my line that sort of identifies the output from the test case, because as you'll see in the refactored version of this, I've added test cases and I plunked them into the middle in order to be in a logical sequence, and I didn't want to have to renumber them. Okay, so that is the class code. Okay, pretty intuitive once you get thinking about it. So how about the client code? So we're going to open up this create vehicle registration invoices precursor. Okay, and this one has you know sort of the naive approach to this. So let's show what this program does. Okay, what this program does is it reads in a file of records, okay, for vehicles, and it prints out invoices for registration renewal. And as you can see, we're currently supporting car and truck. Okay, so let's run this. And I've got a bunch of test data files. I've got car records, car and truck records. Let's just try car and truck. So car and truck records.txt. And it prints out a bunch of pretty invoices, and then it says at the bottom how many it printed. So it printed 73 invoices. Okay. And let's see, the last one was for a car, $300. And then one before is a car, truck. So here's a truck that was $400. Okay, so this is an assortment of cars and trucks, and with pretty realistic kinds of data having to do with cars and trucks in Illinois. It's all cooked up. It's all phony data. Okay? All right, so how do we get that kind of, oh, and then the other thing that it has to do is if we run it with the classic empty file.txt, we want it to have reasonable behavior. And it prints out a separator, and it says 0 invoices have been printed. And I think that's reasonably that's a reasonably graceful end for giving it no appropriate input data. Okay. Okay, so let's look at this. How does this work? Well, interestingly, we say here that we, from my vehicle's precursor import, and I said vehicle, car, and truck, but you can see I never use vehicle. So let's fix that. We're only using car and truck now. Okay, so your version will look like this. So I have a get vehicles. I sort them, and then I call print invoices. And the sorting, this is something that we covered when we covered sorting. if we want to sort by multiple fields, okay, one approach that we can take, because yeah, Python has a stable sort, if we want it first by city, then by last name, then by first name, if we sort it three times in that opposite order, because it's a stable sort, when cities are equal, then it will go to last name, and when last names within the city are equal, it will go to first name. Okay, and then we print the invoices. Okay, so here we go. In get vehicles, okay, we're reading the data, and let's just look at car and truck records and what they look like. They either begin with car or truck, okay, and then they have all the common data, okay, and then the very last thing that they have is their unique data. So the end of the common data is this vehicle ID, this VIN, okay, and then this 10,000 is the gross weight of the truck, whereas for the car, it begins with car, here's the VIN in the end, and then the very last thing is the fuel type. It's hybrid. Okay, so what you can do is you can just look at the beginning of the record to see what it starts with, to figure out what it's a record for. Okay, and this is what we do here. We're creating a list of my vehicles, okay, and if the line starts with car, then we construct a car instance. If it starts with truck, we construct a truck instance, and if it starts with anything else, then we blow it up. And this does that okay. Like we do have a version called car, truck, and motorcycle, because that's where we're going to go. Next, records dot text, and it blows it up. Car, truck was expected. This line starts with motorcycle. Okay, so it's pretty robust in that way. Okay, so we construct either a car or a truck. Okay, and we append either the car or the truck to the list, my vehicles, and we close the file and we return my vehicles. Okay, so how do we construct a car or truck from the input line? Well, it's pretty easy. We strip off the new line, okay, and then we split the fields on the comma into data fields, and then we use these two unpackings in order to unpack all the individual variables. As you can see, the first one is vehicle type, and for the car, the last one is fuel type. And then we just call the constructor. Okay? It's that easy. And then when we do the truck, well, we do the same things, except that the last field is gross weight. Okay, and then we call the constructor. Okay, and the only fancy things that we have to do is when we're calling the constructor, we want year to be a proper int. Okay, it's coming in as a string, and we want the gross weight to be a proper int as well. Okay, so not too hard to do. Could we have done it all kind of inline here? Yeah, but it would make the code a little bit hard to read. And then finally, we're calling print invoices with the vehicles, okay? And again, uh, we've got um, we've got common data, right? So we're trying to print the data that's on the invoice, right? And we've got some common stuff, and then we've got some stuff that's going to be different um, by subtype. Okay. Um, so, and let's look again at the invoices, right? So let's run the car and truck records dot text. Okay. So for instance, let's just look at this. So it says car registration renewal invoice. Okay, so uh, car is going to be different. Okay, if it were a truck, it would say truck, right? Let's find truck. Truck registration renewal invoice. Okay, and both of them have name and address. Okay. Um, oh, and you know what's interesting here? The name and address doesn't have the city, state, and zip. So we're going to have to fix that. Oh boy. Okay, so we'll do it. Okay. City, state, and zip. Okay. So let's look at that. Uh, uh, they should have a city, state, and zip. But we have all this common stuff here. Okay, so we've got the make, the model, the year. Interesting, this says the year too, so that's a problem. I've got to fix that. That's the color. My. I was in a hurry when I did this. And uh, the car has a gross weight, and I mean, the truck has a gross weight, and um, the car has a fuel type. And they both have their appropriate amount due. Okay. Okay, so what do we do? We're missing the city, state, and zip, and we're missing, we've got year instead of color. So I'm going to do some magic here. What I'm going to do is I'm going to go up and pause, and when you come back, it's all going to be fixed. Pausing. Okay, we're back. That was humbling again. Okay, so I fixed this, and let's just go look at this. So here's a car. We have the full address for Wanda Underwood now, including city, state, and zip code. Okay, and then we have the year 2022, the color white, and then because it's a car, it has the fuel type, and then it has um, the appropriate annual fee for a fossil car, 300. Okay, and then if we go up and we find our truck, where's our truck? Yeah, so this is Virginia Wallace in Urbana, Illinois. The gross weight of the truck is 10,000 pounds with a comment inserted, which is kind of nice. And the color is black. Okay? And how did we do this? Well, we did this kind of the naive way, okay? Which is we just asked ourselves what subtype we had. This is, in fact, what we did when we instantiated these, right? So when we instantiated these, um, we said if we have a car then we construct a car. So we have to know about cars and how to construct them. We have to know about trucks and how to construct them. And you would imagine that when we add the motorcycle and if we do the challenge, the snowmobile, well, we'd have to know how to construct them in this program as well, right? And then again, when we come down here to create the invoices, well, we have the same issue, right? We have to know whether we have a car or a truck in order to know what heading to print, okay? So for instance, we figure out the subtype, car or truck, okay? And then when we create the heading for the invoice, we use the subtype, registration renewal invoice, and then we shift the whole thing to upper. Okay, so that's why the car says car registration renewal invoice and the truck says truck registration renewal invoice. Okay? And then we go down, it's pretty straightforward. We're just popping the values out of the vehicle instance, right? So when we read these, we say for vehicle in these vehicles, okay, we figure out the subtype. We do actually check for subtype error in case we run with a file that doesn't have the right subtype. But of course, if we've already changed the program so it knows how to construct a motorcycle, well, then we should have come in here and changed this so it knows how to print the invoice for a motorcycle. But it might be possible that we changed one and we didn't change the other, right? We do the street address and then we do the city, state, and zip. And then we print these as a table. So we put the first column is the one that says make, model, year, color, vehicle ID, okay? And, oh, you know what? I think we want all these to have sorry about that. I think we want all these to have a colon. Yeah, we do. See, I backward engineered this. So I wrote the more sophisticated one first, and then I backed my way into this. And then if we have fuel type, we say fuel type, and then if we have this, we say this. Okay, this is truly humbling. So we're going to run this again. See how we don't have the colons here, but we will. So I think I've already copied the file name, yeah. And there you go. Then you have the colons for these labels. All right, I fixed that because that's what our later version is going to look like. Okay, so of course we're going to print all the standard things first. Okay, and then we're going to check if we have the subtype car. We're only checking the subtype one time. We do it with isInstance, and then we have the variable, and then we have the name of a class. Okay, so it's going to be true if this is an instance of car. That's the subtype. It's an instance of, or if it's an instance of truck, then it's the truck. Otherwise, we have some kind of a program error. Okay. And down here, instead of checking the subtype again in the sophisticated way, we've just saved the data. So we can do car and truck. So we get the vehicle fuel type if it's a car, the gross weight if it's a truck. And then we just call vehicle determine annual registration fee. And the beauty of this, the polymorphism is, if this is a car, well, we're going to get the calculation for cars. If this is a truck, we're going to get the calculation for trucks, right? And then we're putting a separator line down here in order to separate the invoices. And I'm sorry, in the loop, okay, we print the separator line up top, and then when the loop's over, we put a separated line under the last one, and then we print how many invoices were printed. Okay, and this works pretty well. Okay, now so that's our first implementation. It looks pretty good, right? Okay. The problem is, each time we introduce a new subtype, not only do we have to change the class code, the module that has all the classes, but we have to change the client code extensively. Okay? Well, where do we have to change the client code? Now, you're not going to have to work on this one in your coding exercise, but what would we have to do? Well, we'd have to go to two different places and find out. The next place that we're going to go to when you do the coding assignment is the motorcycle, and then if you do the challenge, we're going to go on and do the snowmobile. Okay. All right. So when we're reading the records, okay, we have to be able to recognize each of the subtypes. So when we add the motorcycle, we're going to have to add code here and change the error message, and then we're going to have to create a function for constructing a motorcycle. It's not too bad because we can kind of clone code to do it, right? And then when we get down here, we're going to have to do the same thing. Okay, we're going to have to enhance the code here to recognize a motorcycle. Okay, and then we're going to have to go down here, and we're going to have to deal with the parts of the code with, to the extent that a motorcycle or later a snowmobile has an additional field, right? Well, then we're going to have to add those additional fields, right? And this doesn't seem like a lot of work, but that's because we only have one client program. Okay, one that prints invoices. But let's say we do a lot of things, like we print invoices, or we print lists that are used by people in the motor vehicle department, and we sell our mailing list to vendors, and we do all these things. Each of these would be a client code program that would break every time we added a subtype. So you wouldn't have to just go back to one to fix it. You'd have to go back to all of them. Okay? And that's why this precursor approach isn't where we're going to stop. Okay? So what are we going to do? Well, we are going to take this precursor version, and what I've done is I've refactored it into the starter version. That's the one that you're going to get when you do your coding assignment, that uses better object-oriented coding design principles, such that there isn't as much coupling between the class code and the client code. And so each time we introduce a new subtype, we're not going to break the client code. Okay. Okay, so the starter version that has just the car and the truck. You're going to add the other subtypes when you get to your coding assignment. This is a refactored version of both the class code and the client code. It has much lower coupling between the class code and the client code. New subtypes may be introduced into the class code without breaking the client code. The only thing that you have to do in the client code is just import the new version of the class code, and it works fine. So the two .py files we're going to look at, my vehicle's starter, create vehicle registration invoices starter. And where did these come from? These were refactored from the precursor. Okay. Do you have to know how to refactor these? No. Okay. I don't think you ought to be creating this kind of precursor version. You ought to always begin with a starter version. Okay. But what you are going to have to do is you're going to have to be able to recognize the parts of the starter version so you know what to change when you're adding a new subtype. Again, in your coding assignment, you're going to be adding motorcycle, and if you do the challenge, you're going to be adding snowmobile as well. Okay, so let's go and look at the starter version. Okay. Okay, so my vehicle starter, how's it different? You know what? Let's look at the client code. The client code's the one that had the problem. Okay, the client code's the one that's going to break every time we add a subtype. So let's look at the changes to the client code because that's what drives the changes to the class code. So this is called Create Vehicle Registration Invoices Starter. Okay, and how's it different? Well, it doesn't import as many things. Okay, it doesn't import car and truck. Okay, it doesn't even import vehicle. Why is that? Because it doesn't construct instances of the class hierarchy itself. It relies on another piece to do that. Okay? Well, how does that work? Well, let's look at this. The main is the same. It doesn't change. What changes in get vehicles? Well, we prompt the user for the name of the file. We create an empty my vehicles list. That's fine. And then we say for line and in file, we loop through the in file. And what do? Well, we have a method that we're calling construct vehicle instance. Okay. And what is this? Well, this is the thing called a factory. Okay. I've talked about design patterns in our course, and software design patterns were really popularized by a book called Object-Oriented Software Design Patterns by a group of 4 computer scientists, affectionately called the Gang of Four. And this factory pattern is a light version of 2 of the patterns that they have. So this is kind of the beginner version of how to do a factory pattern. So what does a factory pattern do? Well, it takes responsibility for constructing new instances of a class hierarchy. And in doing so, it hides the details of which subclass you're going to instantiate, you're going to construct. Okay. So, what does it know? Well, it knows all the details of the subclasses and how to construct them. And it also knows the format of the lines from the input file. So we pass it a line of the input file and we get back uh, an instance of what we get back a vehicle. It's in this case an instance of either car or truck. Okay, and then we just my vehicles append the vehicle. Do we know if it's a car or truck? We do not. Do we care? We don't. That was the problem in the last version of the code. Okay, so now we're going to close the file and we're going to return that. Okay, well that looks pretty good. That really cleaned up the code here because we had to be able to recognize, we had to understand all the details of the subtypes in order to construct new instances. And now we've delegated this to this method that's going to be over in the class code module. Okay, and even though it doesn't use the word factory, it is a simple factory. It's using this thing we call the simple factory pattern. Okay, okay, and that changes print invoices. Okay, and now print invoices is a lot simpler. Okay, you can see it never asks for whether this is an instance of one class or the other. Okay. In order to do that, we had to take some of the responsibilities that had been in this client program, and we had to pass them into the classes in the hierarchy. Okay, how did we do that? Well, let's look at this. We print out we're counting the invoices. We print out the separator line for vehicle and these vehicles. That's how we were doing it before. We're going to call a method called get invoice content. So if you don't want to deal with the vagaries of what's on a car invoice as compared to what's on a truck invoice, as compared to what's on a motorcycle or a snowmobile invoice. You have to give the responsibility for knowing what goes on the invoice to the subclasses themselves. You have to put those responsibilities into the class hierarchy. So what we've done is we've shifted responsibility for knowing how to gather the content for an invoice. We've shifted it out of the client code and into the class code. Okay, so we're just going to call get invoice content. Well, which version of that are we going to get? Are we going to get the car version or the truck version or the vehicle version? Well, we're going to get some of each, and we'll see that when we get there. Okay, so what does this return? Well, it returns a title for the invoice, which is a string. It returns a name and address, which is a list, 3 lines, 3 or 4 lines of text, depending upon whether or not I have an address too. And it returns the detail, which is a list of tuples. Okay, 2 strings. The first is the title of the the caption, like make, model, color, vehicle ID. Okay, and the second is the value. Okay, so here's what we do. We have all the data that we need. So we print a separator line. We shift the title to upper and we print it. Okay. For line in name and address, we just print the line, 3 or 4 of them. Okay. We skip a line. Okay. And then we say for content tuple in the detail, so it's a list of content tuples, we unpack them. We have the caption and the value, and then we print the caption and then the value. So how do we format it? Well, we add a colon onto the caption, okay, and then we left justify in 20 spaces. We have 4 spaces in between, and then we print the value, okay, and then we print a blank line, okay, and then we call the method to get the amount due. Now, could we have included that in the information that we capture for the content for the invoice? I thought about that, but I decided since we had a method that calculated the registration fee, that it was better designed to call it directly. Okay? Could one argue that, well, as long as we're going to collect up all the invoice content, we might as well collect up that too? Yeah, we could, but I think it's kind of kludgy. And then we add 1 to the invoices printed. And then when we're done with all these, we just print a separated line and we do a count of the invoices that we printed. So there are 2 things about this that I think are good. One is it's shorter. Okay. I think it's prettier. Right? 2 is we never get into the details of what subtype we have. Okay. What, and then how do we know how to format the invoice the right way? Well, each, we call the class and we ask for the invoice content, and we get back the right title for this kind of invoice, the right name and address, that's the same for all of them, and the right detail, which includes all of the common parts plus added on to the bottom the unique values for a car or for a truck. Okay. If it doesn't have anything that's unique, well, then we just wouldn't add anything onto it. Okay. So this is, now we needed to design the interface for this. Okay. And there is some more complexity here. But the nice thing here is if we add a new subtype, okay, and we go and change the software that we are importing. If we change the class code, okay, well, this is not going to break. This is just going to run forever. Okay, and this is, and again, we just have one of these, right? But in a particular organization, you'd have 2 or 5 or 10 or 100 or 200. Okay, so you don't want to be breaking them. Okay, so then how do we change the class code? Before I get back here. So if we wanted to, let me get back, to the client code. Look at the docstring. Supports all subclasses of vehicle. Okay, so when we add a subtype, all right, we don't have to change this code. Now we, in our little coding exercise, because we're going to have several versions of the class code, we are going to have to point it to the new version. Okay, you're going to go from the starter to just my vehicles. And if you decide to do the challenge, you're going to change it from a starter to my vehicles challenge. But it's not going to change anything else. Okay? Right? So in the real world, you would not be changing this code at all. In the classroom example world, you were just going to have to change this one line of code. All right, so let's go to my vehicles starter and see how this is different. Okay, so this is going to change every time we create a new subtype. Okay, so it says it includes the sub classes car and truck, and I also added in includes simple factory method construct vehicle instance. Okay. So let's look at vehicle. Initially, vehicle in the last version we had, all it had were the instance variables. Okay. Now we're going to add on a method called get invoice content. Okay. And this is interesting. You can have an implementation of a method in the super type, and it can represent a couple of things. One is it can be a default implementation for subtypes that don't provide their own implementation. We don't have an example of that here. Or it could be a common code that's going to be used by the implementation in the subtypes. So what we're going to see, for instance, is that car and truck are going to call get invoice content in the super type, and they're going to add to it. So what do I mean by that? Well, let's just look at car. Okay. So what happens? Well, the first thing that the implementation of get invoice content in car does is it calls the method in the superclass. So it gets all of that common behavior by calling get invoice content on super. That points to the superclass. And what does it get back? Well, the standard stuff, the detail, the name and address, and the title, and then it augments it. Okay? And then in truck, well, we do the same thing. We get invoice content. So we call the super, and then we augment it. Okay? So what are we augmenting? What does it look like in the superclass? Well, the title, the base total is registration renewal invoice. Okay. Well, that's kind of dumb because it doesn't say car or truck or motorcycle or snowmobile. Well, that's okay because when the subtypes call this, they're going to just put the name of their subtype right on the front. Okay, so this is a base value that they're appending to the front of. And then the name and address is the same for all of them. So this is really common code. So we create a list, okay, and then we append the name, street address 1. If we have a street address 2, if it's not the empty string, well then we append that, and then we append the city, the state, and the zip. Okay, so this is not further improved in the um, implementation for the subclass. And then here in the detail, okay, now what we have here is a list of tuples. Now, could we have done this through append? Yes, we could have. A lot of times when you do that with PyCharm, it gives you a squiggly yellow line, and it says that you could just use a list initializer like this. So I did it as a list initializer. Okay, so the first tuple is make, and then we get self.make, model, self.model, year, self.year. I forget what we're doing with this year. I don't think we need this self.year. I think we can, it's going to be self.year. I don't know why we were doing it. I think we were turning it into an int before. Okay, so I fixed that. Okay. Color, self.color, vehicle ID, that. You'll notice that I didn't put colons here. My thought was, with this kind of design, it might be possible for another client program that isn't going to print these invoices, but it's going to display them on a web page. Would it want a colon after all the titles if it was going to put them into a table? It probably wouldn't. It probably would, instead of having a colon, it probably would make them bold. Okay, so this becomes more general if the value that you return it could be used for printing by adding a colon at the end, or it could be used to create a table where you wouldn't want the colon. Okay, so now we've got all of those. Okay, so then we return the title, which is a string, name and address, which is a list of strings, and detail, which is a list of two-string tuples. Okay, and the two-string tuple really allows us to format this in different ways, one for print, one for, say, the web. Okay, and so that's how that works. Now, I'm just going to look at the two subclasses are car and truck, right? Okay, even though we never instantiate or construct an instance of vehicle, we still have a use for this method, get invoice content, because the implementations of the method in the sub classes are going to borrow this code. And let's just go look at each of those. So for the car, okay, get invoice content does a call to get invoice content in the superclass. It gets back the title, the name and address, and the detail. Okay. It replaces the title by the title with car prepended to it. Okay. We take the detail and we append one more content tuple, one with fuel type and self.fuel type. Okay. How do we know it has this self.fuel type? Well, because it's the car. Okay. And so Do we have to do anything to name an address? No, it's going to be the same. We're just going to pass it through. So then we pass back title, name and address, detail. Okay, so the title has another word in front of it, and the detail has another line of detail. And then the truck, okay, get invoice content. We do the same thing. We do a call to get invoice content in the superclass, and it passes back the title, the name and address, and the detail. And we prepend truck to the title, and then we add a detail line, gross weight. And again, if we want the values to be formatted, like say with comma separators, which would be good for gross weight, well, we do that right in here. And that would be appropriate for print, and it would be appropriate for the web. And then we pass back title, name and address, detail. Okay, so that has changed. What about the other parts of these classes? Have we added any other fields or methods to the superclass vehicle? Nope. The common fields are all the same. Okay, we have added the method get invoice content. We don't have any implementation for calculate the annual fee because there's no common part to that. So there's no benefit to having that. Okay, and if we look at car, we still have the implementation to determine the annual fee. That hasn't changed. We have the implementation of get invoice content. Again, that's going to borrow the common behavior from the superclass. And then for the truck, the same thing. We still have the implementation for determine annual fee. And then we have the implementation for get invoice content. Now, remember our factory, okay? Well, the implementation of our factory is going to be in the class library module itself. Okay, now where's the code come from? Well, I'll tell you where I got the code from. If I go back to the old client code, this create vehicle registration invoices precursor. Okay, well, where did I have this? Well, I knew how to construct a truck. I knew how to construct a car. Okay, and then I knew how to test the input lines to figure out the kind that I had to construct. So when I refactored, I just pulled all that code and put it into the new version of the class. Where's the new class? The starter. Okay. So if we look at the construct a vehicle instance, which is the name of the factory, the simple factory method, if the vehicle record starts with car, it calls construct car. If it starts with truck, it calls construct truck. Well, that's just, it came out of the old client code. We just gave it a new home, right? And then for each of the subtypes that we have, we need to construct that instance, right? So what would we do when we added the motorcycle? Well, we'd have to remember to come here to add the code to recognize the motorcycle and call the function to construct it, right? And then, of course, we'd have to take one of these uh, construct methods and clone it for a motorcycle. Okay? It's that easy, right? But you have to remember to, um, uh, to change uh, both of the parts. The simple factory method, and then you're going to have to add one function to construct the new type. Okay? And then, of course, you're going to have to add another subtype. Okay? All right. Uh, a new subtype may or may not have its own instance variable. Okay? Remember, if we're going to charge a flat fee, well, then we don't have to base it on any additional data. Okay? And then, of course, it's going to have its, you're going to have the implementation for determine annual registration fee. Okay, and then you're going to have the implementation for get invoice content, which you can pretty well clone off of what you already have. In fact, it's pretty easy to clone these sub classes off of each other. And again, what about the client code? Well, if you were in the real world and we only had one version of the class code and it was just evolving over time, we wouldn't have to make any change at all. For us, every time we want to be able to run this with new version of the class code, we need to create a new copy of this and point it to the new version of the class module. So we are creating a new copy of the client code in order to accommodate our kind of learning environment. But in the real world, you wouldn't. Okay? And then just to come back to the class code, what did we have to do to the unit testing? Well, the unit testing got harder, okay, because because of the get invoice content method, we need to be able to test that. It's an important part of the infrastructure. So I had to add in expected title, expected name and address, expected detail. Okay, and in addition to testing the constructor for the vehicle, I had to test get invoice content. Okay. I had to do that for the vehicle, and I had to do that for the car. So the car, I tested the constructor, and then I tested get invoice content for car, and then I did determine annual registration fee. We had 3 versions of that. Okay, and then we came down to, we had 4 versions because we had the one that had fuel type plutonium. And then we had to do the truck constructor, and then we had to do truck get invoice content. Okay, and there we are. So that's it. Okay, so what are you going to do? Well, you're going to you're going to take this starter version of both the class code and the hierarchy code, and then you're going to change them first to include the motorcycle subtype. And again, most of the changes are going to be happening in the class code. The client code, you're just going to have to change the import. Okay, and if you decide to do the challenge, you're going to add the snowmobile. And again, most of the change is going to happen in the class code. In the client code, you're just going to have to change the import. Okay. I know this is more complex, but as you can see, the benefits of doing this are that you can have client code that uses the hierarchy all over the place and never break it when you come up with a new subtype. So if we had yet a further vehicle type like ATV, all-terrain vehicle, okay, or RV, recreational vehicle, or something like that, we could do the work in the class module and never have to change the client code at all. All right, I think that is it. Yeah. Okay, so coding assignment version, car, truck, motorcycle, snowmobile if you do the challenge. These are expansion of the class hierarchy to demonstrate the ease of adding new subtypes in this refactored architecture. The end. Good luck with your coding assignment. I'm going to say bye for now. Bye-bye.